My dear student, welcome to School of Fundamental Sciences, SOFS. I deliver some fundamental concepts of physics, chemistry and mathematics for JEE Main and JEE Advanced. It will give me great pleasure if you enjoy these concepts. Third part for calculus for physics. First, idea of average acceleration, RC05. Now, when a particle moves with changing velocity, we say the particle has acceleration. Now first we will define average acceleration. When a particle is moving along the x-axis, at the initial time ti, the particle is at p with velocity vi, and at final time tf, the particle is at q with final velocity vf. Similarly, we can have average velocity delta v vector by delta t vector, delta v vector by delta t, that is v final minus initial by t final minus initial. So you see sample problem on average acceleration. Suppose the particle is moving along the x-axis with the law, this is the law, v is equal to 18 meter per second minus 2 meter per second cube t square. Clearly you see the dimension of 2, because 2t square will have the dimension of meter per second, then you can easily realize 2 will have the dimension meter per second cube. Now we have to compute the change in velocity in the time interval 2 second and 4 second, and then we'll find the average acceleration in this time interval. So first part, at time t is equal to 2 second, vi is obtained by putting 2 second yes in t, so it will be plus 10 meter per second, plus 10 meter per second. At t final is equal to 4 second, again put t final is equal to 4 second in the original equation, so v final will be equals to minus 14 meter per second. So what is the change in velocity? Delta v is equal to, v final minus v initial. It is a vector equation and it is used for, it can be used for computation for one dimensional motion. But this vector quantity should be replaced by magnitude as well as direction. Magnitude is always positive, direction for positive direction plus, and for negative direction minus. So come here. Here the final velocity is what? Minus 14 meter per second. So magnitude 14 meter per second, direction negative, so minus sign already obtained. Minus the initial velocity plus 10 meter per second. So minus of plus 10 meter per second is equal to minus 10 meter per second. So ultimately minus 24 meter per second. It is a change in velocity. Negative sign indicating the what? The change in velocity will take place in a direction, yes, opposite to initial velocity, because initial velocity has a positive direction and change in velocity is a negative direction. So change in velocity is what? Opposite to the direction of initial velocity. Now average acceleration. So average acceleration is what? Delta v by delta t. So delta v already obtained, minus 24 meter per second by 2 second. 2 second is the delta t value. So minus 12 meter per second square. Again negative sign has the same meaning. Next, RC06, graphical concept of average acceleration. So here we have plotted velocity versus time graph. You see at t is equal to ti, suppose it is the graph for velocity versus time. So at t is equal to initial time ti, the particle is at p, so it is the position of the p on the graph when the velocity is vi. At time t is equal to tf, the particle was at q. Yes, it is small q in the graph. I have written capital Q in the figure and the small q in the graph paper. Similarly, capital P in the figure corresponds to small p in the graph. So at t final, q is the position of the particle at q, capital Q in the figure. So it is the final velocity. So clearly it is delta v final minus v final minus v initial. It is the delta t final minus t initial. So clearly delta v by delta t equals to what? Slope of the chord PQ. So average acceleration equals to delta v by delta t equals to, you see, tan theta, and tan theta is called the what? Slope of the chord PQ. Now instantaneous, same concept. When delta t tends to 0, so instantaneous acceleration means what? It is the what? Average velocity delta, average acceleration delta v by delta t when delta t tends to 0. So you see, when delta t tends to 0, obviously delta v must tends to 0. Then the chord becoming a tangent, and then the instantaneous acceleration will be equals to limiting value delta v by delta t, limit delta t tends to 0. In the calculus notation we can write dv dt, more clearly ddt of v is the instantaneous acceleration, and clearly in this condition the chord becoming When delta t tends to 0, delta v tends to 0, the chord becoming a tangent, and the slope of the tangent will give the instantaneous acceleration of the particle at the point P. Now sample problem. We are going to find the instantaneous acceleration at t is equal to 5 seconds, and the particle follows the law given. V is equal to 18 meter per second minus 2 meter per second cube t square. First method, old method, is the concept of limit. Second method, after calculus, you see the second method, calculus approach. The first method, you see v is equal to given as a function of time. At t is equal to 5 second initial velocity, just put t is equal to 5 second minus 32 meter per second. And next we will consider t is equal to 5 second plus delta t. Again same thing. If you have a moment 5 second, so one end 5 second and the other end 5 second plus delta t, it becomes the moment 5 second when delta t tends to 0. Be careful, they never coincide. As close as you can imagine, but never coincide. That is delta t tends to 0. So when delta t tends to 0, we can have the what? Moment 5 second. So you see when final time t 5 second plus delta t, so v final will be equals to what? Put t is equal to 5 second plus delta t, then simplify, we will have this one. So what is change in velocity delta v? V final minus v initial. So ultimately we will have this. Again you note that when delta t tends to 0, delta v must tends to 0, bound to be, bound to be, bound to be. And so that delta v by delta t must tends to a finite value when delta t tends to 0. Come here, you see. So what is the average acceleration? Delta v by delta t. Just dividing both sides by delta t, we will have this one. And we can divide this because delta t cannot be 0. Delta t tends to 0 means what? Never be equals to 0. So what is the instantaneous velocity? We must put the limit of delta t tends to 0. So what is the instantaneous acceleration? Delta v by delta t when delta t tends to 0. It is a limiting value. So limit of delta v by delta t at delta t tends to 0. We will have this one. Again same concept. This term tends to 0 connected by a finite number with minus sign or plus sign. So it can be safely written as 0. So we will have minus 20 meter per second square answer. And the negative sign clearly indicating what? It has the direction same as that of initial velocity, because initial velocity also negative sign, acceleration also negative sign. So instantaneous acceleration and the initial velocity must have same direction. Second method, after calculus you can realize. Another graphical problem. Already I have explained, you see, to find the instantaneous acceleration in the velocity time graph, the slope of the tangent to the curve at the point in question, also at the moment, will give the what? Instantaneous acceleration. So you see this problem. It is a law, there is a graph, velocity versus time. We are going to find the instantaneous acceleration at t is equal to 1.5 second, 6.0 second, 11.5 second. Clearly at t is equal to 1.5 second, the slope of the tangent must be the instantaneous acceleration of the particle at that moment. So you see at t is equal to 1.5 second, a is equal to dv dt. Your slope means tan 37 degree because the tangent makes an angle 37 degree with the t axis, tan 37 degree. Its value is what? Plus 0.75 meter per second square. At t is equal to 6 second, the acceleration is what? Slope of the tangent to the curve at that point. Obviously the slope makes an angle 0 with the t axis. So tan 0 equals to 0. So there is no acceleration. And at t is equal to 11.5 second, what is the slope? Slope, be careful. From the point of intersection, yes, from the, you take the what? You measure the angle from the right side with respect to this point, from the right side into anti-clockwise direction. Be careful. So at 11.5 second, what is the acceleration? Tan 180 degree minus 37 degree. Be careful. So tan 180 degree, it is a slope, the concept of slope in mathematics as well as in physics. Tan 180 degree minus 37 degree minus tan 37 degree equal to minus 0.5 meter per second square.